Okay, so agentic AI, right? It's like everyone's suddenly talking about it,
Yeah.
but is it really all that different?
Well, it's easy to get caught up in all the hype.
Totally. And
Yeah.
that's why we're doing this deep dive. We're trying to cut through the noise and see what's really going on.
Yeah, because there's a lot of buzz, but how much of it is actually new?
Right. So we've got this awesome article by Manav Gupta. He breaks down a lot of the basics. And then two really interesting research papers that get into the nitty-gritty of how these AI agents actually work.
Yeah, the research on this is just exploding right now.
It is. It's so cool. So, okay, first things first. What are we even talking about when we say agentic AI? What makes it different from just regular old AI?
It's a good question because it really is about a fundamental shift in how we think about AI.
Okay, I'm intrigued. Lay it on me.
Think about it this way. You know how a regular AI is kind of like a really smart librarian? You ask it for information and it fetches it for you.
Okay, yeah, I like that analogy.
So an agentic AI is more like having a research assistant.
Oh, now that's interesting. So instead of just fetching the information, it actually does something with it.
Exactly. It can take that information, synthesize it, and even act on it in a way that can achieve specific goals.
So it's like the research assistant could read all those books, pull out the key insights, and then use that to, say, write a report or even design an experiment.
Exactly. And that's a good example because Gupta, the author of that article we mentioned, he talks about 5 key characteristics of agentic AI. He says they need tools, memory, planning, action, and the ability to reflect.
And these are like must-haves for any agentic AI.
They're not just buzzwords. They represent a real shift from AI as a passive tool to AI as an active agent.
Okay, so let's break that down a bit. What kind of tools are we talking about here?
It could be anything from APIs to databases, search engines, anything an AI agent can use to interact with the world around it, to get information or even take actions based on that information.
Okay, so that makes sense. And it makes me think of that AI agent that caused a bit of a stir a while back, the one that could actually write its own code.
Oh, yeah, that was huge. And it's a perfect example of what we're talking about here.
It wasn't just generating code, right?
Yeah.
It was testing it, finding bugs, and even suggesting improvements all on its own.
Yeah, it was like having a whole team of software engineers all packed into this one AI.
It's kind of mind-blowing, right? It makes you wonder where we go from here.
It does make you think. It's almost like there's this autonomy spectrum for AI agents.
Okay, I like that. The autonomy spectrum.
Yeah.
So what are we talking about on, say, the less autonomous end of the spectrum?
You've got your basic language models, your chatbots, your text generators. They're impressive, but they're still very much under our control.
So we give them input, they give us output.
Exactly. But as we move along that spectrum, we get into agents that are capable of much more complex and independent actions.
So like what kinds of things would a more autonomous agent be able to do?
Well, think about an AI that can not only plan out multi-step processes, but can also adapt to new information, even learn from its mistakes without any human intervention.
Okay, yeah, now that's getting really interesting and a little bit spooky, to be honest.
A little bit. But it's also incredibly exciting because it opens up so many possibilities.
It does.
Hmm.
But it also begs the question, how do these more autonomous agents actually learn? It can't just be from reading a bunch of text, right?
That's where it gets even cooler. And this is where our second research paper comes in. They've been working on an agent called Karma. And get this, it's designed specifically for household tasks.
Hold on. An AI that can do my chores. Are you serious?
Dead serious. And what's so fascinating about Karma is how it tackles this concept of memory, which is crucial if you're going to have an AI operating in a complex environment like your home.
That makes sense. I mean, even just to like make a cup of tea, you need to remember where you left the kettle, not just how to boil water in theory.
Exactly. And Karma does this really interesting thing where it distinguishes between long-term memory and short-term memory, just like humans do.
Okay, now I need to know more. How does that work? Does it like write down where my kettle is in a little notebook or something?
It's a bit more sophisticated than that. Imagine this Karma doesn't just see your apartment. It builds a 3D understanding of it. It remembers where your furniture is, the layout of the rooms, all the things that generally stay the same. That's its long-term memory.
So it's like it builds a mental map of my apartment and keeps it stored in its little AI brain.
You got it. But then, let's say you've got this habit of, hypothetically speaking, of course, leaving your keys in a different spot every single day.
Oh no, who would ever do that?
Yeah.
Totally hypothetical, of
Well,
course.
of course. But that's where the short-term memory comes in. Karma is tracking these more dynamic changes in the environment.
So it's constantly updating its mental map based on my latest act of forgetfulness. It's too relatable.
And that's what allows it to be so efficient. It's not wasting time looking in places it knows your keys aren't. It's constantly learning and adapting to the way you actually live in your space.
Okay, that's actually pretty amazing. But how do we know if Karma's memory is any good? How do you even measure the memory of an AI?
Well, that's where this concept of hit rate comes in.
Hit rate. Is that like how often it remembers something correctly?
Exactly. It measures how often Karma can successfully retrieve the right information from its memory when it needs it.
So the higher the hit rate, the more organized and efficient this little AI agent is.
And what the researchers found is that Karma's hit rate was really impressive, which means it's not only good at remembering things, but it's also getting better at using that information effectively.
Okay, so this is clearly way more than just a fancy Roomba. Where do we go from here? How do we take this idea of an AI agent that can learn and adapt and scale it up to tackle even bigger challenges? So we've got this super organized AI agent Karma cleaning our apartments, right? But what happens when the task is bigger than just remembering where I left my keys? What if we want AI to tackle problems that are way too complex for even the smartest single agent?
That's when things get really interesting. It's not just about making a bigger, better Karma, it's about changing the whole way we think about AI architecture.
Architectures, okay, now we're getting fancy. What does that even mean?
Think of it as the blueprint for how these AI agents are structured. Our second research paper dives into this. It asks us this provocative question. Is it better to have one super intelligent AI or a whole team of specialized AI agents all working together?
Okay, I see where you're going with this.
Yeah.
It's like that old debate, one genius versus a team of specialists.
Exactly. And both approaches have their pros and cons. A single, really smart AI is kind of like a chess grandmaster. Super powerful within its domain, capable of planning these incredibly complex strategies.
But maybe not the best at like designing a skyscraper or composing a symphony.
Precisely. You can only be a master of so many things. So a single agent AI, no matter how smart it is, it's always going to have limits, especially when you're dealing with problems that require lots of different skills or knowledge. And that's where these multi-agent systems come in.
Okay, so instead of one grandmaster, we've got a whole team of experts, each with their own specialty working together.
Exactly. And just like a really well-coordinated team can achieve things that no individual could a group of AI agents, each with its own expertise, could tackle problems of incredible complexity.
Okay, this is giving me major heist movie vibes.
Yeah.
You know, where each member of the team has their own unique skill set. You've got the hacker, the getaway driver, the master of disguise all working together to pull off the impossible.
I love that analogy. And just like in those movies, communication and coordination are key. That's one of the biggest hurdles with these multi-agent systems. How do you get all those different AI brains working together smoothly?
Right, because just having a bunch of smart people or AI agents in a room doesn't guarantee success. You need them to actually work together, share information effectively, and stay focused on the same goal.
Exactly. And that's where the research gets really interesting. One of the big challenges they're tackling is how to manage something called agent chatter.
Agent chatter. That sounds chaotic. Kind of like what happens to my inbox when I'm on vacation.
I can imagine. Basically, it's the problem of too much communication. When you have multiple AI agents all interacting, the amount of information flying around can get overwhelming fast. It's like a constant stream of messages, updates, requests.
So how do you keep the AI conversation from going off the rails?
Well, one approach that researchers are exploring is inspired by something called publish-subscribe systems.
Publish, subscribe. Okay, you're going to have to break that down for me.
Imagine you're subscribed to a bunch of different news websites, right? Instead of getting every single update from every site, which would be totally overwhelming, you can choose to only get updates about specific topics that you're interested in.
Okay, so I get my tech news, someone else gets their sports updates, and we're not drowning in a sea of irrelevant information.
Exactly. So in these multi-agent AI systems, it means that agents can publish information to specific channels based on their task or what they're working on, and other agents can subscribe to those channels if that information is relevant to their role.
So it's like creating a more organized and efficient way for these AI agents to communicate with each other.
Exactly. And that's just one example of how researchers are trying to solve these really complex coordination problems with multi-agent systems.
Yeah,
It's a fascinating area of research.
it sounds like it. So we've gone from AI that can organize our homes to AI that's working together like a well-oiled machine. This is starting to feel like the future is already here.
It is exciting, and it brings up some really important questions about the impact of all this. How do we make sure these AI agents are used for good?
Hmm.
And how do we ensure that this technology benefits everyone.
So we've got these teams of super smart AI agents all ready to tackle humanity's biggest challenges.
Yeah, it's a pretty exciting thought.
It is.
Yeah.
But what does that actually look like? Paint me a picture of this AI-powered future.
Well, let's stick with the software development example for a second. We've talked about AI writing code, but imagine entire software ecosystems designed and managed by teams of AI agents.
So instead of just automating tasks, they're actually creating and adapting complex systems. That's kind of mind-blowing.
It really is. And it's not just software. Think about AI managing critical infrastructure, optimizing energy grids, personalizing education and healthcare.
Even accelerating scientific discovery. Are we talking about AI scientists now?
We might be. The possibilities are pretty much endless. But it also brings up some really important questions about control and ethics.
Right, because with all this autonomy we're giving these AI agents, how do we make sure they're still working for us, not the other way around?
That's the million-dollar question, and there's no easy answer. But one thing is for sure. We can't just unleash these AI agents into the world without thinking about the potential consequences.
So what's the plan then? How do we ensure that this technology is used for good?
It's a multifaceted challenge, but one crucial aspect is figuring out how to evaluate these complex AI systems. How do we measure their success, not just in terms of efficiency, but also in terms of their impact on human well-being?
That's a good point. We need to make sure we're not just looking at how smart these AI agents are, but also how they're actually making the world a better place.
Exactly, and that means fostering open dialogue between researchers, policymakers, and the public. This isn't just a conversation for the tech industry, it's a conversation for everyone.
It sounds like we all have a role to play in shaping this AI-powered future.
We do, because the decisions we make today about how we develop and deploy this technology will have a lasting impact. It's up to all of us to make sure that agentic AI is a force for good in the world.
Well, there you have it, folks. Our deep dive into the world of agentic AI. We've explored what makes these AI agents different, how they learn and adapt, and even grappled with some of the big ethical questions they raise.
It's a future full of incredible potential, but it's a future we need to shape responsibly. So keep asking questions, keep the conversation going, and stay curious about the incredible world of agentic AI.
Because the future is being written right now, and it's a future we all have a stake in.